So I'm going to talk a little bit about what's going on in fossil energy, but I'm also going to give it a little bit of perspective from having worked in ERE and now in fossil energy. Because fossil energy is, some folks don't really know what's going on in the office. You might think of fossil energy as being sort of old energy versus new energy. So I'm going to show you what's really new, what's happening in fossil energy that's really sort of at the core of an evolution to a clean energy economy. But first, I just want to sort of go back and just sort of start through a bit of sort of a perspective. So when you think of fossil energy, what do you think? Do you think of rigs offshore Carpinteria in California, 80, 90 years ago? Do you think of a big coal pit in the Illinois Basin? Power plants, maybe the Macondo spill. That's really not what it is. The responsibility of this office is actually tackling the sort of the impacts of the fossil energy system, making sure that the system's safe, secure, environmentally responsible, and then also working in conjunction with all the rest of the work in DOE as we really transition into a new energy economy. And this is helpful to sort of give some perspective. Even with all the transformation we have and the revolutions that David talked about, which are really exciting in everything from LEDs to wind and solar, fossil energy still is a big part of our energy system, and it really speaks to how much energy we actually use, not just in the U.S. but globally. And so you can see here, the sources, where they end up in the various sectors. And although this is changing, this is the 2015 perspective. The 2017 numbers are actually dramatically different already, but it's still a big part of our energy economy. And you can see some of what the changes we've been seeing recently just by this slide alone. So if you look back at 1980 as an example, and then go all the way to the right to the EIA projection to 2040, it's a night and day perspective. And a lot of this really reflects R&D that started at DOE and was taken up by the private sector, especially in subsurface engineering. So the natural gas revolution that you can see there in that blue line really started with R&D that came out of work in everything from synthetic diamonds to breaking rock, to polycrystalline matrices and so on at DOE. And so the big revolution here, the big changes are what's happening in gas and the corresponding decrease in the amount of coal that's burned in the United States, and the really dramatic change in renewable power that David was just talking about. One way of looking at this growth in natural gas is to simply look at this chart. So this is 2005 to 2015. So this is CO2 emissions in the economy, and most of this is because of that gas on coal replacement. There's a little bit of economic, macroeconomy change here, and a big impact from efficiency. But the big piece of this is simply the CO2, the amount of CO2 coming from gas-fired generation compared to coal-fired generation. So I want to talk a little bit about, so what do we do? We're not really as much about producing hydrocarbons as dealing with the impacts. And a big part of the program is creating a commercial pathway for carbon capture and sequestration, or what we refer to as CCS. And so we've got a series of major CCS demos, a lot of work on advanced carbon technologies, especially in capturing the advanced technologies to capture CO2 and concentrate it. And then reducing deployment barriers, especially the market uptake barriers. On the oil and gas side, it goes to water and air quality, addressing impacts like induced seismicity, which is a big issue in the mid-continent, emissions mitigation and quantification, and this is for both CO2 and for methane. And then we're doing work on sort of a future natural gas resource, which is hydrates. Long way in the future, but doing some of that early work in that area. We also have responsibility for sort of energy security. And so this is the Strategic Petroleum Reserve. This is about a 695 million barrel reserve that is really meant to basically be the flywheel in the energy system in the case of any disruptions, both in the U.S. and globally. The office is responsible for LNG, for natural gas exports. And then very involved in a number of these crosscuts. And I think that's also a big theme. When we look at DOE, we increasingly don't behave just within these commodity silos. We're actually involved across a much bigger part of the technology landscape. And for us, this is everything from subsurface to advanced materials, energy, water, supercritical CO2, and looking into the future, looking at the impacts that this program can have on actually help stabilizing the grid as we look at changes in our generation fleet. So we have a number of demonstration projects underway, and right now is actually a really exciting time because a number of these projects are actually getting to sort of that critical, here's the press release phase. And so the first one is the Air Products facility in Texas. This is a hydrogen processing facility. They've captured 3.3 million tons of CO2 at this facility since it started in 2013. The next one is the Archer Daniel Midland's ethanol facility up in the Mid-Continent, up in Illinois. This project's going to go online sometime, probably the end of the first quarter, and this is going to capture about 1 million tons of CO2 on an annual basis and sequester it and store it in the ground. It's also going to be the first time that we've had one of these major projects that has taken advantage of what's called the Class 6 permit specifically for storing CO2 for long periods of time in the subsurface. Next project, the Petronova project, and actually the timing is great. They had their press release this morning, their commercial as of this morning. This is a 240 megawatt plant down in Texas, and this is going to be capturing about 90% of the CO2 that's generated from the facility, and then that CO2 is then pipelined and used in an EOR project. So it basically creates the business case for doing something with CO2. And then finally, the last one is the Kemper project, which is in Mississippi. This is a nighttime picture from a short time ago as they've been basically going through startup. The flare you can see there is the flare of syngas from this facility, and this is also going to be another one of these really exciting storage and sequestration projects. This is about about 3.3, I think it's about 3 million tons of CO2 per year. In addition to this, we've also had a number of big sequestration partnerships around the country. The focus of these partnerships have been really trying to get a really accurate characterization of the subsurface so we know where we can store CO2 safely in the subsurface for long periods of time. And in the process of running all these projects, we've sequestered about 10 million tons of CO2, which is really exciting. So we're basically creating the foundation for really accelerating dealing with CO2 in the energy economy. Boy, that's sensitive. I mentioned LNG exports, and I just wanted to share. This is something else that the Oil and Gas Office does. Is following on authorizations from FERC. This office then works on providing authorizations for LNG exports out of the U.S. And you can see basically the curve there. To date they've authorized almost 17 billion cubic feet of gas per day. The context for this is a little bit more than 50% of global LNG market. And so the U.S. has authorized a number of these projects that are basically ready to take LNG elsewhere in the world. A good way of looking at this is in many cases is going to be natural gas that goes elsewhere in the world. It displaces coal. And so if you remember earlier, that slide that I showed that talked about the coal and natural gas curve, globally this does the same thing. It's a big part of that global change our CO2 footprint, change the nature of the energy economy. Through basically taking advantage of natural gas that's come out of early, the volume of which has come out of early DOE R&D. Also, we're right in the middle of Strategic Petroleum Reserve modernization, and so this is an effort to modernize basically the infrastructure at all the storage sites that we have down on the Texas Gulf Coast. And again, remember, this is almost 700 million barrels of oil. And so they've just announced that they're going to try to basically stand up the sale of about 8 million barrels of oil. And this process it's underway right now. And the proceeds from this are going to be used to modernize this architecture, modernize the systems, and make sure that it's safe for a long period of time going into the future. I need to mention what's going on with our national lab partners. So the Office of Fossil Energy, like many of the other applied offices, has responsibility for a national lab. Ours is NETL, and it has several sites. And so you can see here where these sites are located in West Virginia, Pennsylvania, and Oregon, but also you can see the diversity of what this lab does. And so when you think about fossil energy, but then you look at, for example, at the Albany, Oregon site, and they're working on materials performance and modern, advanced alloy, structural material development. It really goes to modernizing materials that are used in the fossil energy fleet as we ask that fossil energy fleet to increasingly perform in a different way, basically balancing against increased penetration of renewables. You need new materials to be able to do that, and so that's a lot of what the lab's doing as part of their much broader and really aggressive R&D portfolio. So I want to talk a little bit about where we're going. So you've seen a little bit of where what we're doing from the standpoint of the demos, some of our responsibilities, but increasingly, like the rest of DOE, we don't think we're not thinking in a commodity silo. We're thinking in a much broader sort of integrated context. And so, for example, advanced energy systems, looking at power systems, and also how do we modernize existing plants. Also looking at what do we do with CO2 that comes out of industrial facilities, not just power plants, but industrial CO2. And combining that with advanced separation technologies, membranes, solvents, sorbents, and so on. And then trying to basically look at both the inputs and the outputs out of these systems, both electricity, heat, and gases and products, and then combining that with the carbon technologies, the utilization technologies that really go to what do we do with the CO2 and what do we do with these materials, whether it's storing CO2 in saline reservoirs, which in many cases can be combined with enhanced water recovery, combined with desalination. CO2 use, new technologies for use, using new catalysts, new mineralization technologies, and which basically goes to products to market. So we're in the midst as well of a change where CO2 is going from being something that, it's a waste product, to where we're starting to think of CO2 as being a commodity. It's something that has value, and increasingly will have value as we come up with the new technologies and processes to do something with it. And then that starts driving and connecting us up with other parts in a very unique way with other parts of DOE and with the ERE. For example, on the fuel side, connects us up with low carbon fuels, which then has an impact on the vehicle sector. If we start looking at where we have renewable power, especially where at certain times of the day or certain market conditions we have cheap electricity or cheap heat, can we start combining that into some of the separation technologies in ways that we would not normally have envisioned? And how does that then tie into the rest of the energy system, and eventually having an impact on things such as the grid. So you can see what we're doing is trying to think of the overall energy system. It's not just CO2, it's thinking about everything we do and how does it connect up with all the rest of the parts of DOE. Thanks very much.